Chapter 3 starts off with section 3.1 that talks about pairs of lines and angles. To start the section, we need to first address some vocabulary. There are two types of lines that do not intersect. The first type of lines that don't intersect are called parallel lines. Parallel lines are lines that do not intersect and are coplanar. Remember, coplanar means that they lie on the same plane. So parallel lines, again, are lines that do not intersect and are coplanar, meaning that they lie on the same plane. The second type of lines that don't intersect are called skew. Skew lines do not intersect and are non-coplanar. So that means they do not lie on the same plane. And below here, I've given you two examples of parallel lines and skew lines. First, we have parallel lines. These two lines, M and N, are parallel because they lie on the same plane and they will never intersect. And I've given you two examples of skew lines. Our first example are the two blue lines right here. They will never intersect, however, they are not lying in the same plane. So these two lines, although they're going in two different directions, they will never intersect each other since they are lying in two different planes. This plane on top is actually like hovering above this plane on the bottom. And the two planes will never intersect, so the lines on them will never intersect. The second example is this cube here. So we have 6 different planes intersecting all along the different lines. This line right here is in the back of the cube. This is in the front of the cube. So even though those are going in two different directions, they are on different planes and therefore will never intersect. The symbol for parallel lines are two lines that look just like this. It just kind of looks like two lines that are parallel to themselves. So if I wanted to state here in our example for parallel lines, if I wanted to state that line M is parallel to line N, I would write it just like this, line M parallel to line N. If I wanted to mark on a diagram that two lines are parallel, it would look like this. You just basically use little triangles to indicate that the two lines are parallel. Also included in this section is when two planes don't intersect. If two planes don't intersect, they are called parallel planes. So just like parallel lines are two lines that don't intersect, parallel planes are two planes that don't intersect. So to put all this together, I've given you a diagram and we're going to answer these questions 1 through 6 according to the diagram here on the left. So number 1 says blank is parallel to blank, and we're supposed to fill in those blanks with lines. So looking at the diagram, I see that these two lines, N and M, are marked with the little triangles to indicate that they're parallel. So I can just simply state M is parallel to N in that first statement. The second one, lines blank and blank are skew lines. So remember, skew lines are lines that don't intersect but are on different planes. So looking at the diagram, line N and line K, those do intersect, so they cannot be skew. However, line K does not intersect with line M. They're not parallel because they're not on the same plane. They're on two different planes, but they don't intersect. So line K would be skew with line M. Number 3 says blank parallel to blank, and this time we are supposed to use planes to answer this. So we have plane T and plane U. Those two planes are not intersecting, so we would say that they are parallel planes. So capital T is what they're calling the blue plane, and capital U is what they're calling the green plane. Number 4 says lines blank and blank are intersecting lines at blank. Let's just stop there for now. The only two lines that are intersecting in our diagram are lines K and N. And it's also asking where they're intersecting at. We know that two lines intersect at a point. However, when we look at where lines K and N are intersecting, that point is not named. So let's just name it ourselves. Let's just call it point P. So lines K and N are intersecting lines at P, and there is a blank not shown containing them. So what we're referring to here is on a line, we have at least 2 points. So there's at least 2 points here on line K and at least 2 points here on line N. So therefore, we would have 3 non-collinear points, which would determine a plane. But again, that plane is not shown. Number 5, the small directed triangles mean that the two lines are parallel, which we talked about previously in number 1. And number 6, lines blank are parallel to plane U. So the two lines that were parallel to begin with were lines M and N. They were on the plane T that was parallel with plane U. So therefore, anything on plane T would also be parallel to plane U. So lines M and N are parallel to plane U. And I'll say that again, when you have two planes that are parallel, anything that the two planes contain are also parallel to the other plane. Example 1, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? Part 1, line or lines parallel to line ED and containing point C. So looking at our diagram, we need a line that is parallel to line ED and contains point C back here. Remember, if I'm finding a line that's parallel, it needs to be in the same plane. So the only line containing point C that is parallel to line ED would be line GC. And remember from chapter 1, if I'm naming a line, I need to use a line symbol or the word line. I also name a line with just 2 points. Number 2, line or lines skew to line ED. So remember, skew lines are non-coplanar with line ED. So if this is line ED, I want any line that is skew to it, so therefore it's not intersecting it and it's not in the same plane. So line FH would be in the same plane. It doesn't intersect ED, but it's in the same plane. Line GC is in the same plane. It doesn't intersect it, but it's in the same plane. So those are just parallel lines. The lines that don't intersect ED would be lines like AF and BH. Also included would be lines AG and BC because they do not intersect line ED and are non-coplanar. And the last one you might think could be skew with line ED is line AB. However, I could slip a plane to go through line AB that would also go through line ED. So therefore, ED and AB would be coplanar because we would have at least 3 non-collinear points that we could determine a plane with. So even though there's not a plane shown, I could put a plane through so that it contains line AB and ED at the same time. So therefore, ED and AB are actually parallel lines, not skew lines. Number 3, line or lines perpendicular to ED. So remember, perpendicular lines intersect, and they intersect to form right angles. So we're looking for anything that forms right angles with line ED. You can see that line HD is perpendicular to line ED. If HD is perpendicular to line ED, so is FE. CD would also be perpendicular to line ED, as well as GE. And that's actually it for number 3. Moving on to number 4, plane or planes parallel to plane ABH. Let's first identify plane ABH. That's the top of the box up here. We're looking for planes that are parallel to it, so planes that don't intersect it. So looking at the diagram, the front of the box intersects plane ABH. This side over here also intersects it. This side over here also intersects it, and the back of the box back here also intersects plane ABH. So therefore, those could not be parallel to the plane. Therefore, the only plane that is parallel to plane ABH would be the bottom of the box down here. Remember, you name a plane using 3 non-collinear points. We are given 4 for the bottom of the box, so we're only going to pick 3 of them. We use the word plane when we are naming a plane, so plane, and we're again just going to pick out 3 points. Let's just pick out G, E, D. And there we have it. That's example 1 for you. Next, we have 2 more postulates. Now remember, we have a lot of postulates and a lot of theorems that we already know that we can now use in the proof process anytime we need to prove anything we're asked to. So these are just 2 more to add to your arsenal of different reasons you can have in the proof process. The first postulate we're going to look at today is postulate number 13, the parallel postulate. If there is a line and a point not on the line. So here we have line L and a point P not on it. So again, if there's a line and a point not on the line, then there's exactly 1 line through the point parallel to the given line. So again, we have a line with a point P that's not on it. There is only 1 line that can go through point P that is parallel to line L. That's the parallel postulate. Postulate number 14, the perpendicular postulate. It's a lot like the parallel postulate. If there's a line and a point not on the line, so again, we're going to start off with line L and point P not on it, then there's exactly one line through the point perpendicular to the given line. So again, we're starting with line L, point P not on it. There's only one way to draw a line through point P so that it is perpendicular to line L. So again, these are two more postulates, the parallel postulate and the perpendicular postulate. The parallel postulate states that if I have a line with a point not on it, there's only one way to draw a line through that point so that it's parallel to your original line. And the perpendicular postulate states that if you start off with a line and a point P not on it, there's only one way to draw a line through point P so that it is perpendicular to your original line. Example 2, the figure shows a swing set on the playground. Assume parallel and perpendicular lines. Number 1, name a pair of perpendicular lines. So looking at the swing set, I see a bunch of them in here. I see that this here is perpendicular with the line down here. This line is perpendicular to the same line. These two lines would be perpendicular to this line right there. And again, we're only supposed to name one pair, so let's just pick that this line is perpendicular to this line. And there we have our answer. Line DH is perpendicular, there's my symbol for perpendicular, to line HI. Number 2, name a pair of parallel lines. When I look at my diagram, I see several. This line, this line, this line, and this line. So let's just pick out one pair because that's all I'm asked to find. And there's my answer. I picked out line DH, which is right here, parallel to line EI. And notice I used the symbol for parallel. Number 3, is line DH perpendicular to line LM? So let's look at DH. DH is right here and LM is right here. If I actually think about how a swing set is constructed, this line right here would be going in a different direction than this line down here, and therefore they would never intersect because the front of the swing set would have to be here and this would be behind it. So this is kind of going sideways and this one's just going straight up and down. So therefore, these two lines would never intersect, but they are not on the same plane. So we would call that not perpendicular, we would call those skew. So take a look at how I answered that question. I said, no, the lines are non-coplanar and do not intersect. Therefore, they are skew lines. In order for them to be perpendicular, they would have to intersect. But these lines don't intersect at all, but they're not parallel since they're not on the same plane. They are skew since they are non-coplanar. And the last part of this section has us identifying certain angle pairs. Let's look at the diagram. We have two lines, line 1 and line 2, that are cut by this line, line T. A line that intersects two or more coplanar lines at different points, so this definition right here, is called a transversal. So again, this line T would be the transversal of line 1 and line 2. We're going to use this scenario where we have two lines cut by a transversal to now identify all the different angle pairs that are formed by that transversal intersecting those two lines. So the first one, two angles are blank if they have corresponding positions. So these are called corresponding angles. And what they mean by corresponding positions, it's as if I picked up this line and put it on top of this line. It'd be the angles that would overlap. So if I picked up line 1 and put it on top of line 2, angle 2 would be on top of angle 6, 4 would be on top of 8, 1 would be on top of 5, and 3 would be on top of 7. So those are corresponding angles. Let's just pick one of those. We would say angle 2 would be corresponding to angle 6. Although we do have other angle pairs that are also corresponding. And before we move on to the rest of the angle pairs, let's next identify the exterior and the interior that are formed when the transversal intersects the two lines. When the angles that are formed are on the inside of the two lines that were intersected, that is called the interior. The angles that were formed on the outside of the two lines that were intersected by the transversal, those are called exterior. We'll need to use these in order to identify the next set of angle pairs. So the next one says two angles are blank if they lie between the two lines, so we're talking about the interior angles, 3, 4, 5, and 6, and are on opposite sides of the transversal. So we're talking about interior angles on opposite sides of the transversal. These are called alternate interior angles. Again, these are called alternate interior angles because they are on opposite sides of the transversal, so that's the alternate part, and on the inside of the two lines that were cut by the transversal, so that's the interior part. So we're talking about angles 3 and 6 and 4 and 5. We'll just write down 1 for an example. The next angle pair are called alternate exterior angles. Two angles are alternate exterior angles if they lie outside the two lines. So again, that's the exterior part. So we're talking about angles 1 and 2, 7 and 8, and are on opposite sides of the transversal. So again, they're looking at different sides of the transversal. So in this case, it would be 1 and 8, 2 and 7. We'll just write down one of those as an example. The last angle pair are called consecutive interior angles. Two angles are consecutive interior angles if they lie between the two lines. So again, that's why they are interior. So we're talking about 3 and 4, 5 and 6, and on the same side of the transversal. So in this case, consecutive means they're on the same side of the transversal. So that would be angles 3 and 5, and then 4 and 6. But again, we'll only write down one example for our notes. So here again, these are more angle pairs that you will need to remember. Corresponding angles, meaning that they're in corresponding positions, so 1 and 5. That means I'm picking up this line, putting it on top of the other line, and the angles that match up, so 1 and 5, 2 and 6, 3 and 7, 4 and 8. Alternate interior angles, meaning that they are on different sides of the transversal and on the inside, so 3 and 6, 4 and 5. Alternate exterior angles, meaning that they are on opposite sides of the transversal and on the outside, so 1 and 8, 2 and 7. And then consecutive interior angles, meaning they're on the same side of the transversal and on the insides, we're looking at 3 and 5, 4 and 6. I would for sure write down some examples with a picture that I can refer to in my notes so that you have these for upcoming tests and quizzes. As always, write down anything you have that you don't understand so that we can cover it in class before we move on to do the homework over this section.